All right, I'm going to go over the last couple problems that are from the notes that I posted. Sorry if the PDF is a bit fuzzy. I'm going to post it as two separate documents. I don't know what's going on. So here's one more story problem when it comes to writing an equation and solving for stuff. Starting at the age of 40, right? Starting, so that's initial. An average man loses 5% of hair every year. At what age should an average man expect to have half of his hair left? So we remember we want to make a times b to the x, or p1 plus r to the power of t, or p1 plus r over n to the t, or p e r t. All right. For this one, we could try to treat it as either the ones with the rates in it that are either continuous or are compounded annually. Just because hair is a natural thing, let's go with the one with the e in it. So we have our initial value at age 40, right? An average man loses 5% of his hair. At what age should he expect to have half his hair left? So this one's kind of weird. All right. We're not really too sure what the initial value is. We know how old the man is, but not the value. So we could treat it like P is 1, right? P could be 100 for percent. We're not really too sure. And honestly, once we get to the second point, it really doesn't matter. So let's just say P is 1. We know rate is 0.05, but it's a negative because we see loses. So let's figure this out. So we have 1e negative 0.05 t. And we want to figure out how much time would it take for him to get half of his hair. So if we had 1 as our initial value, 0.5 is half of it. So then when we divide both sides by 1, we get 0.5 e0 negative 0.05 t. We want to solve for t, so when we rearrange this, you might be tempted to say log base e of 0.5 equals negative 0.05, but we really should remember it's not convenient plugging that in. We want to change that to the natural log of 0.5 equals negative 0.05 t. So divide by negative 0.05. And that will give us our time in years. So on your calculator, you should be typing that in. I don't have a calculator on my iPad, so I'm using Desmos on my laptop to help me out here. So I'm doing the natural log of 0.5 divided by negative 0.05 and we'll get about 13.86. But remember, we want to round up for time, so we get 14 years. After 14 years, the average guy will have lost half of his hair. That's not quite what the story asks. It asks at what age. All right. So that means if he starts at 40, and it takes 14 years, sorry, the guy will be 54 years old. All right. So let's see what else we have going on here. All right. So the next one we're going to talk about is how to expand and condense. So we want to expand, which means going from 1 log to 2 logs, which sometimes we have addition, sometimes we have just subtraction. We'll talk about it. We look at number 1 on the screen right now. We have log base 2 of z to the 6 and the third root of x. Those are two things being multiplied, right? And our log rule says log of a times b will equal log of a plus log of b. So when we separate these, we get log base 2 of z to the 6 plus log base 2 of the third root of x. We separated it. Now let's deal with that exponent. Our other exponent rule says if we have log base a to the n, that power will come out in front of the log as the coefficient. So that will turn 6 log base 2 of z plus, and then we have this third root. Third root is a variable, right? The third root of x is the same thing as x to the power of 1/3. So that comes out like this. All right, so that's our final answer. Over here, we have division, but first we have to deal with this exponent. So that comes out log base 2 times log base 5 of u over v squared. The last log rule we have is if we have a over b turns into log of a minus log of b. So here, that 2 stays on every log we have. And we do the log of the numerator minus the log of the denominator. But again, we still have one more coefficient to deal with, so we have log 2 times the log of u minus 4 times the log of v. Let's try to work the other way now. We have these two logs being subtracted. First, we have to deal with these the coefficients, though. They turn into exponents for what the log is being taken of. So this will turn into log base 2 of x to the 4th minus log base 2 of y to the 2nd. Now we have this subtraction to deal with. And if we just saw above, if we had division inside the log, it turns into subtracting 2 logs from each other. So we have log base 2, and then in parentheses, we will have a fraction. This first one goes on top, the second one goes on the bottom. So that is our answer right there. Over here, we have a little bit of work. I'm going to rewrite this so the 1/3, instead of looking like a fraction, it looks like a coefficient. Which means, just like the 6 here, the 1/3 becomes an exponent. So we have c to the 6 plus log of a to the 1/3. And as we saw above, a fraction exponent is the same thing as a root. Now we have this addition, though. And the way that we deal with that, when we write one log, we end up multiplying the two things inside the log. So that would be our final answer. The next type of situations we have is when we have to solve for a variable. This one was extra credit on the quiz. So let's look at this. Notice how we have log 9, log base 9, log base 9. That's great. We have all of them the same lace. Every term here has a log in it. So first we're going to combine these two logs on the left, and we just said that if we have addition going on, this turns into multiplication. All right, now we have log base 9 on both sides. That's very convenient to us because they just kind of cancel out. Okay, so now we have 4 times the quantity of x plus 7 equals 46. We can divide 4 on both sides, so we get x plus 7 equals 11.5, and then minus 7 on both sides, so we get x equals 4.5. We only get one answer here because we had x plain. All right, if we look at number 6, it looks very similar, but over here we have no log, so this is going to be a little bit different. But first we can still do what we did on the other side. We have 8 times x minus 10 equals 2. We have no log on the other side, and right, we have log base 10 because we don't see a base. The base is 10. This one's the example where we only have log on one side, so we actually need to convert it from a log into an exponential. So here our base is 10, then we take the other side of the equal sign, so 2, and that equals what we're taking the log of. So that's how we get our exponential. We can do the math, you get 108 x minus 10, divide both sides by 8, we get 12.5 equals x minus 10, add 10 on both sides, so we get 22.5 equals x, right? Those were kind of simple, right? But we have this a little bit more complicated one for number 7. We can still multiply these two things together because we have this addition, and then we have the natural log of 10. Again, these two logs cancel out, sort of. They both disappear. And we have this now. So we need to treat it just like we would as any other type of algebra. We distribute that x to both. So we get x squared plus 3x equals 10. We want to get this equal to 0, so we can use our quadratic solving. So we have 0 equals x squared minus 3x minus 10. So we're looking for two numbers that multiply up to negative 10 but add up to negative 3. So 0 equals x minus 5 and x plus 2. So that means x equals positive 5 and x equals negative 2. We have two answers here, but we need to be careful. All the other answers are positive, and those seem to be fine. We do have an issue here, and if we remember our graphs, our log, for any log, right? For any log, our domain is x is greater than 0. But that's for like log of x or ln of x, right? We want the number inside the parentheses. Once we do any math inside the parentheses, we need that to be positive. So let's check. We can do ln of 5 plus 3, that's 8, that checks out. ln of 5, that's positive, that checks out. So that's one of our answers. Once we do this, negative 2 plus 3 is 1, so that checks out. But then when we get to this ln of negative 2, that does not check out, we would get an error in our calculator. So this one is, remember what we call, an extraneous solution. All right, so on the test, make sure we're being careful. If you have a problem like this and you get two answers, double check. And more often than not, the negative one or the very small one is not going to work because we get a negative inside the parentheses for the log. All right. Hopefully that answered any remaining questions. Good luck on the test tomorrow.